Hello guys, very welcome back. In this video we'll be learning about the basic terminology related to the space, right? So the first very important terminology is what are asteroids. Asteroids are small rocky body orbiting the sun, right? Same as the planets, but these are primarily found in the asteroid belt that is between Mars and the Jupiter, right? Now the broken pieces of the colliding asteroids forms meteoroids, and when the meteoroids they come close enough to the earth, right, but they don't completely burn and they hit the earth, they are known as meteorites. I mean, right to fall, you can remember by that term. The second is meteor, right, just the opposite case. They don't fall, they vaporize, and we say shooting stars. Next, the comets are the globular mass of the ice and the gas orbiting the sun. When it comes close to the sun, it begins to vaporize, leaving a tail, right? This is known as the comet's tail, right? Next, we will differentiate between the terrestrial and the Jovian planets. The terrestrial planets are the Mercury, Venus, Earth, Mars. The Jovian planets are the Jupiter, Saturn, Uranus, and Pluto. These are high density, these are of low density. They are very small in size, they are relatively larger in size. The terrestrial planets are closer to the sun, farther. Less moons, more moons. Rings absent, rings are present. Solid surface, gaseous surface. Less spinning, more spinning. Less spinning causes less flattening at poles. More spinning causes more flattening at the poles. Video will be learning about one of the most accepted theory as far as the origin of the universe and is concerned, that is the Big Bang theory, right? So it started with a Big Bang, right? Now, how did we know that there was an explosion? Now, Hubble saw in his telescope that the galaxies, the stars are moving apart, they're moving away. That means they were at some point, right? Now this one point, via extrapolation of universe, yields an infinite density and temperature at a finite time, that is 13.8 billion years ago in past, and this point is known as singularity. Singularity lasted only for Planck Epoch, right? That is from the explosion to 10 to the power minus 43 seconds, right? By the way, in universe only 10 to the power 60 is that unit is possible, that is the maximum unit, right? Now it is said that during singularity, that is during the Planck Epoch, there was super force, right? We'll explain what is super force. It is a combination of all the forces, right? And this was an unstable universe, right? Now since this was highly unstable, and it started to expand and started to cool because it started to expand, right? So the first from 0 to 10 to the power minus 72 seconds, there is inflation. At 10 to the power, that is first microsecond, proton forms. You know how does proton forms? Because the quarks here were able to combine, right? When the quarks combined, proton formed at 1 microsecond. At 10 to the power minus 2 second, right, nuclear fusion starts. That is, neutron and proton, they combine to form nucleons, right? And from 10 to the power minus 2 second to 3 minute, the nuclear fusion continues, and at 3 minute fusion ends. At roughly about 3.8 lakh years from the Big Bang, a recombination occurs. What is the recombination? Recombination, when the electron and proton had combined together to form a stable atom, right, a neutral hydrogen atom, a thermal radiation was emitted. Suddenly universe becomes transparent. The CMB radiation were the earliest light of the universe, that is cosmic, microwave, and background radiations, right? Representing earliest seeds of future galaxies. right? Because we know after 300 million, that is 30 crore years after the Big Bang, first star and the galaxy were formed, right? So CMB radiation, this process of recombination. And how does the light produce here? Because when electron and the nucleus combined, a stable atom formed and thermal radiation was emitted, because thermal radiation was not able to be absorbed by this new stable thing, right? So energy was released and universe became transparent. First star formed after 300 million years ago, and 13.8 billion years ago, this is the present day universe, right? So now there is another timeline, very deep. Hello guys, very welcome back. So this video is all about the Big Bang theory, which is the most accepted theory among all the theories. Now the Big Bang theory divides the complete evolution and the origination of the universe into two parts. The first is the radiation era and the second is the matter era, and there are roughly 11 epochs, right? So the first is the Planck Epoch, where the temperature was 10 to the power 40K, and it was just after the Big Bang, and no matter existed, only energy and super force existed, which is a combination of gravity, strong nuclear force, weak nuclear force, and electromagnetic. The Grand Unification Epoch, 10 to the power 36 Kelvin, and 10 to the power minus 43 second had just passed, right? The gravity got separated here, and the left combined force was known as Grand Unified Force. The next is the Inflationary Epoch. The temperature was 10 to the power 33 Kelvin. The time was 10 to the power minus 36 seconds, right? And there was a rapid expansion of universe, and now the strong nuclear force had also separated, right? So the left out combined force of weak nuclear force and electromagnetic force was known as unified force. The next epoch is electroweak epoch. The temperature is 10 to the power 20K, and the time passed is 10 to the power minus 32 seconds. All the forces got separated, right? So independent forces, right? Next is the quark epoch. 10 to the power 16 is the temperature. 10 to the power minus 12 second has passed, and too hot, right? The temperature is too hot to combine the quarks into atomic particles. The sixth epoch is the hadron epoch, right? 10 to the power 10 Kelvin is the temperature. 10 to the power minus 6 second has passed. The quarks here bind together, forming neutron and proton. Lepton epoch and the nuclear epoch, right? The proton and neutron fused to form the nuclei, creating the first element, helium. The atomic epoch was somewhere around 3000 Kelvin, right? The temperature of universe had gone well below, so that the electron now can come into the neutron and proton influence, and this recombination formed the hydrogen. Next was the Galactic Epoch. It was around 200 million years, and the helium and the hydrogen atomic clouds dotted the universe, small pockets of gas. Gravity caused the atoms to collect, and the cluster of atoms became the seedling of the galaxies, right? So after the 8th epoch, that is after the nuclear epoch, starts the matter era, because up till now only there was radiation, and after this there was a this nuclear epoch is the watershed moment, right? Finally we have stellar epoch, 3 billion years. In galaxies, star formed. With star, tremendous ripple effect starts, and the present shapes formed, presently seen. The heat caused conversion of hydrogen and helium into other elements of universe, and became the building blocks for the planets, the moon, and the life, right? So that was all about the Big Bang and all the important events, right? So thank you.